Okay, now we're going to go to problems. Why do we engage in problems? And I label those, or I lump them all together with homework problems and classwork problems. Why are we doing these problems? Okay, all right, so the first thing. How have you experienced doing problems in your math class? Either classwork or homework. How do you do them? Right? You just work through them. Are there solutions? You check answers. How are you doing them? Right? And what do you like and dislike about the problems you do in a math class? In a math class, do you actually do any problems in the classroom? If you do, how do you do them? Like she just tell you, you write them down, they give you the answer. Do you talk to your neighbor? And then homework, what do? Do you just get a list and you do them? And then you check answers, or there are no answers, there are answers? Okay, what do you think? How do we engage in problems in a math class? What do you do? Let's start with Dallas, and then we'll work our way through.
I said teachers usually just give us examples after their lecture, and then we show our work either in groups or and usually on the whiteboards or.
Oh, okay. All right, nice. And then there's some solution somewhere. I mean, you don't get a solution, but someone tells you if they're right or wrong. Right?
Yeah.
You check. If 8 people have 6 and 2 people have 4, it's probably 6.
Yeah.
Okay. All right, Sam, what do you think?
I said like when I'm doing homework, I usually do like 4 or 5 problems at a time, and then I'll go back and check like just the odd solutions, just so I can make sure I'm not totally off on what I'm doing.
Okay. And do they normally assign you odds or evens or?
Yeah, I would say for the most part it's odds, but they'll give you like 2 evens just to make it so you just don't copy stuff out of the back of the book.
Yeah.
I guess you have to like write down your work anyway, so it doesn't matter.
Yeah.
But sometimes if like we're doing just problems like maybe for studying or something like that, if it's easy, I'll just stop and just say, okay, I know how to do this one, so it's a waste of time to keep going.
Yeah, I like that. Why practice what you're good at? Right? Anyone else want to add? Is there something different? I just assumed we were kind of all the same. Nathan?
I've done some stuff back in high school during where you just discuss it.
Oh.
And then there's other things where like you get groups and you race through like the competition you can do through.
Yeah, it's a facet. Yeah. But other ones you didn't actually work them out, you just talked about how you would.
Say like how you work through this problem.
I like that. I like that a lot. That's unexpected. That's kind of cool. Anything else?
In one of my classes, we did like do the homework by yourself, but if you have a question, like you can ask your neighbor and have them like work it through with you. And like if our teacher heard us like giving someone the answer, then we got like that grade.
Scolded or reprimanded, yes. Yeah. Because when you get to the real world, you're not allowed to collaborate with anybody. I don't know if they told you that. You know, as soon as you graduate from college, you never can collaborate with anybody. It's hush hush. Yeah. All right. Anything else?
We had we had a math club, and the T-shirts one year were is just like the Hunger Games logo,
Right.
and then on the back it said, "May the odds be forever in the back of your book."
That's awesome.
And so, I thought that was pretty
I don't know where that was going. That's quite funny. Okay. Why do students do problems? So why do homework problems? Why do classroom problems? What's the point? All right. How about Maddie? What do you think?
I said like the purpose of homework and classwork is to learn and understand the material that was presented in class, like to have extra review and to make connections and then transfer the material from like short-term memory to working memory and then eventually long-term memory.
Nice. I like that. All right. Anyone else? Anyone wants to follow on it? How about Jack? What do you think?
A lot less.
It's not a competition.
Practice.
Practice. We're doing it just to practice? What are we trying to practice? What's that?
What we just learned.
What we just learned? So I become fluent at some kind of a procedure? Is that the deal? I'm not saying it's right or wrong. I'm just saying, is that what we think? Homework is just to practice the procedure? Right. Fluency? Right. What else?
If you do it enough, you would hope that it would help them remember.
That could definitely be. Yeah, repetition. Remember, if you're going to brute force it, if it's behaviorist, then you need repetition. You need lots of it. Because you need to forge new neurons, right? New synapses. You don't forge neurons, you forge synapses. All right? But you definitely need that. So if you're trying to brute force something, they do need to practice.
But I think it depends on the kinds of questions that you're giving them too. Like, I mean, if you open a math book, there's going to be questions to ask, you know, for them to do the procedure to solve for X or whatever, but then there's gonna be like application questions too in there.
You'll see the back of all math books, the ones nowadays at least, the sections are scaffold. Like they'll do this, then they'll use that to do the next one. So they scaffold to the last section is all about. Put it all together. Well, you're right. It's scaffolding, all that good stuff. All right. I'll do some other things too, but keep in mind, especially the fluency part and all of this, this is something that students understand. You're not doing homework problems, especially the fluency, until you get them right. You're doing them so that you can't get them wrong. That's a big difference. I'm not doing it to get it right. I'm doing it so that I can't get it wrong.
I actually wrote on mine, practice makes perfect.
Yeah. Perfect practice makes perfect.
Right.
But yes.
Practicing.
Yep. Okay. But think about a basketball player. They're not practicing free throws until they make it. They're practicing until they can't miss it. That's what we're trying to do. That's a whole different way to think about problems too. Okay. All right. So we talked about constructive understanding. Some things that also you should think about. We do problems to challenge us, to see what we really know and what we don't know. We do problems to see what we really understand and what we don't understand. We're challenging two things, knowledge and understanding. Okay, so we practice for fluency, absolutely. But we also challenge for knowledge and understanding. All right? Okay. The other thing is we actually do problems so that we can see how they're similar and different. So we can now get an idea of how this all fits together. Okay, similarities and differences, that's a big deal. Right? How are the answers similar? How are they different? How are the prompts similar and different? How are the givens similar and different? Well, look at all that stuff. Okay? Are we all right with all that? Okay. I'm sure I've said it 100 times, not to you, but I say it all the time. You can tell a horrible math teacher like that, look at their homework. If their homework's 1 through 21 odd, they have no idea what they're doing. Because what the hell are you doing? You've given no thought to what homework problems you want these kids to do, which means you've given no thought to the examples, you've given no thought to the lectures. I guarantee you're just throwing a book up on the board. All right? That's how you tell good and bad teachers, math teachers. They pick problems that are related to the things they want to do. All right? Okay, is that all right? That's kind of a soapbox deal, but there you go. Okay, learning goals. How do we do learning goals? How can we incorporate that into how we do problems, how we engage in problems? Right? So remember, knowledge and understanding, that's what I'm asking about. How do we have kids engage in problems such that we bring out knowledge and understanding? What do we do? What can we do? Okay, how about Nathan? What do you think? How do we incorporate knowledge and understanding?
Okay, so
How can we?
I just said, like, if you're working on problems that start with reinforcing knowledge and then start to force you to, like, ask questions, like, how does this connect to our knowledge, and then force it to
You're picking specific or choosing problems such that the students have to ask themselves these questions? Okay, okay. All right, anything else? We do knowledge or understanding.
I said that you can have students explain whether their answer makes sense or not and why, or like, I kind of wrote it wrong, but like, if you're going
Exactly.
over their homework answers and they get it wrong, like have them find where their mistake was and explain why it was wrong and then explain why
Yeah.
the correct answer is
Yeah.
right. And that'll help
Yeah.
them understand.
So two ideas there, right? One is you could have them justify their answers. I want one sentence to tell me why you think this is correct, right? Why in your work you think it's correct. And the other is if you get it wrong, I want you to look back. You could even be specific, and you'll see this in my test corrections. I'm specific about, I want you to identify your error. Is it conceptual or procedural? Is this just you missed a minus sign and it was plus, or do you really have no idea what's going on? All right? And if this is neither here nor there, but they always say procedural. And if your sentence starts with, oh, I just forgot, that's conceptual. It means you have no idea what you're doing. All right? So there are a lot of them are conceptual, but it's a great idea. All right? Next, how else can we do? How can we incorporate knowledge and understanding in all this stuff?
I said like do a practice problem together, and then have students like do one similar to it on their own, and then doing that same problem as the teacher doing it, so that students can see what they did wrong and what they did right.
Oh, nice. Like compare the solution part. Yeah, I like that. Compare the solutions. Anything else?
I put have students explain or justify the steps that they make.
I like that too. Yeah, that's definitely a conceptual idea, right? That's the understanding part. All right. So now when I say conceptual, I mean understanding. Anything else?
I also said like when you're doing a practice problem, if like a part of it is something that they already know how to do, like asking them like, okay, what do I do next? To like assess their prior knowledge.
Okay.
in the practice
So
problems.
verbal questions while they're doing the actual problems.
Yeah,
Absolutely.
And like have them do the problem, like if it's something that they already know how to do.
Nice. So say that to me again. So if they know how to do the problem, so I think I
So
lost
like
you.
if it's like a new concept
Uh-huh.
and I'm teaching it and then it's like in the middle of the problem it's like, okay, now we're just solving for X or something and they already know how to do that.
Okay.
And it's like, okay, now where do I go from here? And have
Gotcha.
them do it for you instead of me just
Yeah, perfect.
doing the rest of it when they already know how to do that.
Yeah, I like that. So engage them in the parts that they already know how to do, the prior knowledge. Absolutely. And that's going to fit quite nicely in the learning theory. Let's engage their prior knowledge when I'm going through problems. Right? Absolutely. Anything else? Okay. If you are seeking knowledge only, repetition. And I would tell them, give them 10 problems, say, hey, look, if you can do, and this is very sketchy, I don't know how much of this I do, but maybe say, hey, look, do these 5, and if you're good, stop doing them, but then come back an hour later and do 1 more. If you can do it, then it's sunk in. I'm good with that. All right? But don't just do the first 2 and say, oh, I got it. Come back. All right? So maybe that's a knowledge thing. The understanding part, and we had talked about this, but maybe actually include conceptual questions. In your homework assignment, do problem 1, problem 2, and then at the bottom, say this is a conceptual question. How are problems 1 and problem 2 similar? How are they different? Right? What's special about problem 6? Add conceptual questions to your homework. Right? That's how we can get at understanding. Right? Force them to answer these connecting questions. Okay? All great ideas, though. Anything else? Okay, how about learning theory? How can we do learning theory? Procedural, declarative, or I'm sorry, how students learn. Sorry about that. So how can we do how they learn? Okay, so learning theory, let's get the behaviors part out of the way, right? If you need to do knowledge, just repetition, repetition. I think we've covered that, right? That's the deal. And just make sure they get it. All you want to do is, like Maddie said, long-term memory. So do it about 6 to 10 times and then come back and see if they still do it. Okay. All right, Janelle, what else? How can we do the constructivist part?
I said engage students by asking questions, and then they are like understanding it. You think let them finish it, like give them a little bit of time to finish it on their own, and then just like quickly kind of give them like a gist of it, like finish it yourself on the board, just so they have the rest of it.
This is a great point too, especially for conceptual part. If I'm doing a problem and they're having an issue, you don't just solve the whole thing. You give them maybe 1 more step or a hint. You need them to connect the understanding. Watching you do a problem, this is the hardest thing too. When students have issues, they'll come up and say, I need help in this problem. You'll do the problem on the board and they'll all go, oh, I totally get it. And that's the biggest bunch of crap there is. I get it. If taking a test was you watching me take the test, we'd all get A's. Of course you get it. Someone that knows how to do it explained it to you. All right, that's the biggest misconception in education. Watching people know what they're doing doesn't mean you understand anything. It means you're good at watching people that know how to do it. All right, so don't just have them watch you. Say, well, this is what I do in the next step, and then try from there. Give them a minute. If they don't, then do the next step. Don't give them the whole thing. Excellent, excellent, excellent. That's a great constructivist idea. Okay, anything else? What else could we do?
What about having the students like write their own like word problem?
Not a bad idea either. Yeah. Especially if you could do, and I love the idea, but maybe make it a little broader where they connect. So how does it connect to prior knowledge? What in here are you trying to get at? Or what concept? So why did you write it the way you did? Make sure they make the connections. I love it. Yeah. Otherwise, you'll just get, I had 10 fish in a barrel, I shot 1, how many fish do I have left? Great word problem. I guess technically still 10, that was a weird example. Anyone else? We're all, anyone else?
Maybe with like definitions or theorems or something, you could like have them come up with their own way to like remember it,
Yeah.
and then go around as a class.
Yeah, that'd be perfect. And what, I don't want to say kooky, but what special thing to you would make you remember this, right? Because we're all different. Maybe, I can't even think of the term, but maybe it makes me think of socks. Argyle socks for some weird reason because of the things. And now when I think Argyle socks, I get the, yeah, absolutely. Yep. How does it connect to you? That's a great constructivist idea. right? And then have everyone say it because maybe they'd all, resonate with other people. Never even thought of that. That's a great idea. Great idea. Anything else? Okay. We could always, at the end of our homework, you have a place where they tell you how all the ideas were connected. Maybe they tell you a core concept. Maybe they tell you how this related to the prior knowledge. All right. Maybe they tell you how they changed some belief they had in math. When I say that, blank in here, but it could be as simple as they always thought that negatives times negatives were negatives. I don't know, but they always believed that. But it's some mathematical idea that they had a misconception about. Okay. Good stuff. Anything else? Okay. And then the motivation thing again. Just show them how where the value is in actually doing this. Because what we're going to ask them to do is, it's easy to crack open your book, do 1 through 10, check your answers, and then close your book. We're asking them to do some things that are much more time consuming. I want you to answer conceptual questions. I want you to make connections. That's a big deal, right? And students aren't going to want to do that. So show them how that's going to connect to how they study for exams, how they actually perform on exams, all that stuff, right? And how that connects to the notes that we're doing. Right? So this all is connected now. It's not isolated. Not lecture notes problems. Lecture notes problems. All connected. Okay. All right. Okay, let's try the same thing. I'm still back and forth. You want to see my framework, or you want to just try one on your own first? I said this one, let's try one on your own. I know you said yes. Let's try this one on your own. This one for me is a little bit in depth. So.
Oh, did you say your phone reminder?
Just let me
No, I don't think that. It starts like at 8 o'clock.
Oh, it's like 8 or 5.
Yeah, so it's like a live thing.
Oh.
Yeah.
What really to do?
Okay, thanks.
Are you supposed to?
I'm just supposed to listen
But she's not really listening.
to it. I'm not.
Best.
About the budgets, I guess.
I get that.
As treasurer. Yeah, 'cause of this one.
So we're writing, some kid comes up to us.
And says, yeah, how should I do homework problems? Right? Homework or classwork problems. They say, how should I actually do homework problems? You say, this is how you should do it. Right? Okay. All right, let's start with Dallas. What do you think? Or what's your framework?
So for my how to do homework, I did write down the question, and then go, then start going through, write down what you know from the question, and then go through the process from what you learned in class and through your notes, but try and do the question without looking at your notes first. And then clearly write the process either by numbering each step or whatnot. If you get stuck, try and find where you're getting stuck at. Ask classmates or teachers for assistance, hopefully with hints instead of solutions.
Okay.
And then keep trying, asking questions, going through the process until obtaining the solution.
Nice. That's nice. All right. Okay. All right, Sam?
I said look at the problems that are assigned and then identify concepts that you'll need to use on a certain problem. If you're struggling with knowledge-based stuff, repetition is the way to go. The more problems you do, the more times you visit it, you're helping with your working memory to your long-term memory. After doing a couple problems, maybe check your answers with the odds so you're doing so you know what you're doing is correct and you're not just doing a bunch of wrong problems. And then once you know it's correct, justify why it is correct to yourself. And then before handing in your homework, maybe talk to a partner and justify to them a couple of the answers that you got and why you got them. If you have questions, ask. And I wrote down also, make sure you write down all your steps so that if you do have a question, the person that's helping you can notice exactly what you're doing wrong.
I like that. It's a nice warm-up, too, the next day. Turn to your partner and justify it. All right, Janelle, what do you think?
I said write down a brief description of what the problem is asking you to do, and then write down the original problem or bits of information along with bits of information given to you. So if it's a story problem, write down what's given to you, and then if it is a story problem, draw a picture of what is going on so you kind of know what's exactly going on, and then work out the problem as you go through the process. Write down what you're doing. So if you're solving for X, but solve for X.
Oh, nice. Like this.
If you subtract 3, actually write down, even though you do the head in your math in your head, and then write a formal solution. Either a sentence for a story problem of what it's asking for, or like write in the correct notation. So like x
Oh, nice.
equals this.
I like that. That's missed too a lot. It's always 3.
Yeah.
And Katie.
I wrote the same write the problem on your paper. I put try to solve the problem on your own, and then compare or check your work with the examples and notes that you did in class. If you know that you got the wrong answer, look for minor details like missing a minus sign or something like that. That could cause a mistake, and then try working out the problem step by step with the examples. And then when you do, like when the correct answer is given to you, like by the teacher or whatever, to ask for the correct solution, and then make notes comparing to your wrong solution. And then I just wrote stay organized on your paper, work top to bottom, and then maybe have them like if there's something that they really just like didn't understand, or they got it all wrong and they thought they were doing it right, like Google search ways to remember said concept.
Oh, okay. Cool. I like that. Technology. Nice. Maddie?
For mine, I put to like write down the question being asked or a summary of the problem if it's like a long explanation or a short problem, and then before you start your work, make comments about like which method or like which definition you're going to refer to, and then if you like don't know where to start, then refer to your notes and write down which notes you used to help you with that problem. And then work out the problem and show all your steps along the way. And then once you're finished looking at the problem, box your solution. And then check, if you can, like check your answer to see if it's correct. And then after that, if you see that your answer was right, then state like the main steps you took for that. And then if it's wrong, state why it was wrong and then recorrect it. And then after you make the comments under that, like if you have any questions or unsure about some step of the problem, then write those there, and then you can ask them in class the next day.
Nice. Definitely, yeah. Write your questions. I like that. Kristen?
I said always write down the question and then write down like what you know about it and then what you want to know. I said always show your work, so if you have a question on the homework, and you have if you have a question about it, then you can figure out like where you messed up in the steps. Do practice problems for test preparation, review definitions of a term if a step doesn't make sense to you, ask a friend for help but not the answer.
Nice. I like it.
Like most people, start by writing down the problem so you understand what it's asking you to do. And then identify everything that you know and need to know so that you can get rid of any non-needed information. Make sure you write down each step as you go just to keep track of signs that you may miss, or like later on if you can refer back to certain steps to see if you made a mistake. Repetition is key, so
For the knowledge part,
for
yeah.
the knowledge part. And so like in that aspect, like do all the problems assigned, and then if you feel like you need to do more to become fluent, then
Yeah.
have at it. But
Yeah. I always did that. I did a minimum of what I thought they needed. And if you needed more, but I'm not going to give you 20 just because.
Yeah.
You know.
Another thing would be to summarize key concepts of the homework and then connect to previous lessons.
Nice. That's the first understanding part right there. Yeah, the first connection. Good. Good.
And then box your answers and keep track of questions.
Yeah. The box answers are big. You don't want to go 180 tests. You don't want to go looking for answers for homeworks. Yeah.
So I said make sure you read the directions carefully.
Good.
And gather any information you can from the problem. If possible, look for any prior knowledge that can help you with the problem.
Nice.
Then try to work through it. If you run into a problem, check the notes for the book first. If that helps you finish it, check the answer and see if you were wrong. If you were wrong, you look back at the notes and still see if you can find a trouble spot. If you still can't find a trouble spot, ask a neighbor or the teacher for some help. Don't expect to have full
Nice.
answer, just expect like a hint. And then if you get that done, try to work through the problem, just like it, and then see if you can figure it out.
Yeah, I do like that. Once you get your question answered, you need to work a similar problem. Right? Again, it's that idea that we watch someone that knows how to do it. So, excellent. All right. Okay, let me show you mine. This one's a little bit more in depth. This actually fits or kind of links into how I think students should study too. So there's a lot to this. So the first part is obviously read the directions. Make sure you understand every single word, all the notation. If you don't know that, if you don't have the knowledge, stop. Go find out what it all means. You know what students will do when they read a problem, they come to a word they don't know? They'll skip it. Awesome. If they come to notation they don't know, they'll skip it. Fantastic. Right? So maybe on the side you should write the definition, write what the notation is, all that good stuff. Okay? So this is assuming if you know what you're doing, then obviously you work the problem. I'm a huge fan, like I said before, there should be worked out solutions everywhere. I don't know what making kids struggle and Googling, and it wasn't a comment on UK, but Googling things, I don't know what that does for them. Right? They should have an idea of what they're doing right and wrong. They shouldn't have to struggle. I don't know. So this idea is you only go to 2 if you have an issue. So if you have an issue, then what you need to do are these. So if you get stuck, right? So as you work the problems, you're not looking at books, you're not looking at solutions, you're not looking at any of that stuff. But if you all of a sudden do get stuck, then you need to identify why you're stuck. Be specific. I don't know how to take an integral, right? I don't know how to do a derivative. I don't know how to rationalize denominators. I should understand why I'm stuck, not just, hey, I'm stuck. Right? Once you do that then, once you figure out why you're stuck, then go to your notes. Go to the book, go to the solutions, go to a friend, get help. All right? Once you get help, determine how to actually fix your issue. So you get help, you know what's going on. When you figure out what your issue is, you need to write that down. That's what I call a key concept. And that's how the key concepts are connected in the lessons. It's the things that we learn. Right? If you go through an entire homework assignment, you didn't learn anything, it was a waste of time. All right? So when you figure out what helped you, write it down. They will never write it down. They'll just get help and move on. Then the last part is prove it. If you said you fixed your problem, prove it. Do another problem. Work another one. Okay, once you completed the problem, always check your solution, no matter what. You don't have to have the exact same solution. You're just checking to see, actually, if they are different, you want to check why. Right? That'd be a good comment, too. Why are they different? All right? So it's not so much that you have the exact same solution I do. You're just checking. If your solution is incorrect, so you did all the work and you checked your solution and it's wrong, you thought you were right and you're wrong, that's a misconception. You thought you did something right and you actually were not right. You need to go figure out what that is. And I want you to label that as a misconception. So after you did 10 homework problems, I should see key concepts, I should see misconceptions. Right? I should see a list of these things because we're treating homework as a learning process. Okay, and then while you do the homework classroom, I want you to actually look at the problems and compare them. How are they similar? How are they different? Why did we do 10 and not 12? Right? Why did Tekin assign 1, 7, and 15? Why didn't he assign 14? You should know these things. If you can't understand why I didn't assign 14, you don't understand what the homework's about. Right? Similarities, differences, that's what you should do. At the very end, I want a core concept. What was the big idea in this whole entire section? Why did I do this homework? Then I want basic concepts. What were my givens? What were my prompts? What were my solutions? Do some of them have infinities? Some of them not have solutions? I want to know these things. All right? And then once we do all that stuff, return to your notes and add things that you learned. Modify your notes. That's a comprehensive homework strategy. All right? That's my framework. I made a little note at the bottom. If you do this, then when you come to class and ask questions, it's never, how do I do number 6? It's, I got to number 6, I don't know how to do the integral, how do I do that part? It's not do the whole problem 6 for me. I should know exactly what your issue is, where I can help you, not, hey, do problem 6. All right? Okay, anyway. So a little more in depth on that one. That'll come full circle to how I think students should study. Okay, your homework is now, your frameworks don't have to be anything like mine, it's whatever you want, that they're yours, own them. But if you would, type them up. And then I want you to actually justify parts. I want to know why you're doing the things you're doing. If you want them to have a line down the center and do comments, I want to know why. If you want them to read the question, I want to know why. If you want them to write down the question, I want to know why. Okay? So just justify each step. Okay? Yeah.
You want us to write our entire framework and then
And then just if you could do side by side somehow, it'd be cool, but it might get kind of jammed. So I don't know.
Maybe
Well,
like put a fourth.
I think I swear to God I was thinking that actually, but I don't want to sound stupid. But yeah, however you can do it, I know it's your poetic license. That's it. That'll be due next week, and then that's all there is. So have fun, do whatever you do when you're not here.
It's easy. I know.